Hello, everyone. My name is Vinod Dragautam Rao, and I'm pleased to moderate the CERA Week Agora conversation presented by IHS Market. The topic for today's conversation is trusting robots. We will be discussing about robotics and artificial intelligence and the role they play in the energy sector. Today, I'm joined by Daniel Bruce and Nick Tillman. Thanks for joining me today, Nick and Daniel. At the outset, given the current COVID-19 situation, we do know technology plays a greater role in almost all the sectors in today's global world. In that aspect, I'm sure technology has also been penetrated deeply in the energy sector as well. And within technology, I think robotics has been there from time immemorial. And I think in 2020, if you may let me know that the robotics has really been in the oil and gas, the utility sector within the energy sector. And my first question for you, Nick, will be, okay, how do you see the trends in robotics and artificial intelligence within the energy sector, especially in the field of inspection, asset maintenance, and optimization?
Yeah. For one thing, the main driver in that area for using robotics instead of human beings is safety. Inspecting large assets, particularly assets that have held things like gasoline and explosive liquid storage tanks is dangerous. And, literally people get killed doing that every year. So there's a major safety incentive behind it. There's also an economic incentive because inspecting and maintaining these assets involves literally removing them from service, which can often lead to lost production. So the incentive for the industry is definitely there. And there are organizations that are set up to promote the use of robotics in inspection and maintenance of large assets. There's an organization called Sprint Robotics that was set up around 2015, and it started off with just a couple of oil companies and some inspection companies and some European robotics companies. And now it has hundreds of members, and just about everybody who's involved in that industry is a member. And obviously, there's lots of challenges in that area. I mean, we can talk about that maybe a little bit later as we go through the conversation, but it takes a lot of collaboration between not only end users, but the whole value chain and supply chain, and including inspection companies, robotics developers, service companies. It's a major undertaking.
Yeah, thank you. And to you, Daniel, how do you feel AI and robotics has sharpened the utilities industry? I know Vinsa AI is more into utilities industry. How do you think AI and robotics has shaped the energy sector, especially when it comes to utilities?
Yeah, absolutely. So we're seeing a lot of trends. Some of these are old trends that are gaining some additional momentum and traction due to COVID. Some of these are just old trends that continue to play out. First of all, the most obvious one is just a focus on increasing the efficiency and productivity of employees. And so today, for example, in an inspection scenario, where a worker might be able to do one inspection per day and then potentially even miss some items of interest in that inspection. Robotics and AI kind of offer the opportunity to take a lot of that legwork off the human's plate and potentially make that human 10 or even 20 times as efficient. So that's an old trend that we see continuing to grow. Specifically with COVID, though, we're seeing a significant interest in any type of technology that can help enable remote work. So people who traditionally would have to be on site performing an inspection, if you can kind of put them behind the digital wheel of a robot, have the robot be the physical on site presence and sort of capture the footage remotely, that's something that can be done from home. It can be done technically from anywhere in the world. And then one other trend that we're seeing that we're really excited about at Vinsa is a shift towards more of a collaborative human as trainer type of model. And what I mean by that is instead of focusing humans' time on actually performing tasks like inspections, shifting humans' time toward training and improving the importance and the accuracy of robots and AI. So in an inspection scenario, that might look like instead of the human performing that inspection, using a robot to do the automated collection of imagery data, and then using technologies like computer vision to take, tens of thousands of images that have been captured, filter those down to just a small set of anomalies, and have that human look through those anomalies. It's much more efficient, and companies that are able to connect the dots in the right way can save time and money, and also use that human input to improve the efficiency and the performance of those algorithms over time. So it creates this really virtuous feedback loop that we're seeing a lot of traction with.
Okay. And do you think, Daniel, is there a widespread adoption of the AI and robotics in the utilities sector? Is it more like a push from the technology providers by the AI and robotics, or there's a pull from the actual energy sector clients? So they needed the technology better than the technology providers pushing the robotics and AI technology to those clients. What do you see, especially in the US and other parts of the globe?
Yeah, good question. And look, there's definitely a mixed bag there, depending on who you're talking to. There are definitely leaders in the industry that are kind of setting the drumbeat for others. But I would say, Vinta works across a number of different industries. We see a uniquely fast adoption curve from energy and utilities, and we attribute that largely to advances in technology. The fact that energy has a lot of use cases where there's a need to put humans in harm's way. For instance, inspecting like highly pressurized equipment or doing an inspection in radioactive containment. These are necessary evils right now, and drones and robots kind of allow us to take humans out of harm's way and kind of put them behind the scenes. And then there's just so many high impact, high value use cases, from equipment inspection to creating an inventory of digital assets. Even just to give a flavor of a type of use case that we see coming up a lot. For instance, in nuclear facilities, they might have tens or hundreds of thousands of old analog gauges. The obvious thing to do with those is digitize them, so replace them with an IoT device. That can literally cost thousands or maybe tens of thousands of dollars per device, and it's just prohibitively expensive. And so we see use cases like that are really driving an accelerated curve, because there's so much need for, but there's also so much opportunity to use these technologies in energy. And so we're seeing an exciting, very, very accelerated curve there.
Okay. Nick, to you, do you see a push from the technology providers to the IOCs and NOCs? I know in robotics, it's into inspection of pressure vessels, storage tanks, and so on. So do you see a push from these technology providers, or there's a pull from the IOCs, NOCs across the globe for such robotic inspection technologies?
I think it goes both ways. We're pushing harder than the IOCs are pulling, but that's only because they're by nature cautious. But there is a significant pull. The whole premise behind both Sprint Robotics and the industry and in the inspection of large assets is safety and getting humans out of confined spaces. And to a large extent, the things that were just talked about are happening. I mean, anything that you can do remotely with cameras, using computer vision to monitor assets. You can read gauges now using computer vision. You can use smart glasses so that you can have sort of centralized control centers that are looking after assets, based on either a digital twin or somebody wearing the glasses and using things like virtual reality or enhanced reality to actually do work on the location. So there's a lot of that is going on. The difficulty comes in when you are trying to do something that we've been working on, inspect the storage tank with a robot. You have to be sure that getting the robot in the tank and getting it to do an inspection isn't more dangerous than the process of actually taking that tank out of service. And when it comes also right down to it, the robots and the AI and all that is pretty cool, but the people who are responsible for managing the assets are looking for data. And they'd prefer to get that data without putting somebody in danger. But, as a robotics provider, we have to figure out how to give them not data that's just as good as what they're getting, but to actually get them to put an effort behind doing it. It's got to be better. So that's really on us to figure out how to do that. And there are companies, and one of them that's actually a leader in this area is Dow Chemical. They've set the target of no human confined space entry. I think it's 2025, whatever it is. And they're actually backing that up with some real metrics. And in some cases, they've made pretty significant strides by eliminating a human confined space entry. There are a lot of things you can do with robots right now that give you the same level of data, and in some cases they're actually requiring senior management approval. So if you put a human in a hazardous confined space, you have to justify it, and that's the way it's going to need to go, because it is a complex thing.
Yeah. And one other question to you, Nick, would be: do you see North America region is in probably the forefront of these technologies, and the clients who adopt these technologies are from North America, or do you also see an interest from the international oil companies present elsewhere globally, especially the national companies across the globe? Do you also see from them an interest of adopting these robotic inspection technologies?
I think there is interest globally. I think the U.S. and Europe are the real focal points, because more of the technology resides in the U.S. and Europe. In fact, Sprint Robotics was started in Europe, in the Netherlands. But there's interest in Asia, Malaysia, Thailand, Australia. Sprint Robotics is active there, and also in South America. In the end, these technologies are global. If I have a robotic technology that's going to save lives in the U.S., I think somebody in China is going to want to use it, and vice versa. And it also takes a lot of collaboration. And one of the things that Sprint is doing as well is they're putting out guidelines for robotic inspection. So, you kind of have a roadmap as a developer for what you actually need to do, and what are some of the things that have to happen, like explosion-proof certifications and things like that. I will say, as somebody that's developing technology, it looks a little bit easier when you're looking at it from a distance than actually when you get into the details. I think that's true about a lot of things, but particularly in this area it is.
Okay. And one other question to you, Nick, is how do you think the advent of artificial intelligence has probably propelled the robotics, especially in the oils and gas sector, to the next level?
Well, one thing that artificial intelligence and machine learning lets you to do is make sense of a whole bunch of data. And one thing you do when you use sensor technology is you collect a lot of data, and you probably don't know what to do with 90% of it. AI and machine learning helps you make more sense of the data, and get better predictive capabilities, particularly as you use it over time, and the algorithms start learning what's happening. You can predict failure, and you can plan your maintenance more around actually risk-based maintenance when the risk of something failing is high because of the data, rather than I've got to take this tank out of service every 10 years because I have no idea what it looks like on the inside. And specifically in one of the things that we're working on at IN Robotics is a kind of a GPS system for a storage tank, for inside a storage tank. And we've been able to, and we're using advanced algorithms around both the geometry of a tank and location sensors, et cetera, and making it a lot more precise. But one of the problems was getting it to kind of reset quickly enough so that you could actually follow a robot around a tank. because what the technology does is actually, kind of works like a self-driving car. It maps the inside of the tank, and then it finds its position on the tank. And we're now working on some machine learning algorithms that really speed that up and really make it useful, so we can track data to the actual location. And if we can do that, then we can start using these advanced techniques, predictive maintenance techniques, to reduce the necessity to take tanks out of service and do a much better job of maintenance without using human beings.
Okay. And Daniel, how do you think the artificial intelligence and computer vision has enhanced the robotics, especially in the utilities sector?
Yeah, definitely what Nick said. I mean, I think that's probably the biggest opportunity. Companies are just sitting on gold mines of data right now. And so figuring out how to use AI to kind of unlock insights from that's certainly a big trend. A trend that's very near and dear to our heart here at Vinsa is using what's called unstructured data. So natural language data, and then especially imagery and visual data, to extract trends. Those are tasks that are traditionally very difficult for machine learning algorithms, but modern computer vision technologies, visual perception technologies allow companies to, for example, take a video or an image of a location or a piece of equipment within their plant and not just treat that as raw bytes or raw pixels, but actually understand what's going on in that image. So understand this is a pipe, understand individual objects that are in that image, and make higher order assessments. Like, for example, this is a pipe that has rust developing on it. This is a pipe that is leaking, and make assessments about, based on those visual conditions that are typically have been out of reach. So what we find is really robotics and drones solve one problem, right? They enable the capture, they're really moving sensor platforms. So they enable the capture of acoustic data and visual data and all sorts of rich information, but they cause another problem. They kind of generate this massive haystack of information. And so AI is really the key to unlocking value out of that data and connecting the dots. So you have to have this capture platform, some way or some mechanism for storing all of that information. And then AI is really what completes that value chain and allows you to pull rich insights out of that data that you can make kind of actionable decisions from.
Okay. And Daniel, what do you think are the current challenges or barriers for the widespread adoption of AI and robotics in inspection within the energy industry? Do you think it's the cost, the regulations, the return on investment, the payback period? So what are the key current challenges and barriers?
Yeah, good question. And it's hard to narrow this down to just one or two, but I'll highlight a couple that we see as common themes. One trend that we see, or one challenge that comes up a lot, is just resistance from the workforce. And this might be that the people whose jobs are being impacted or automated. It might also come from upper management, just having a lack of trust for the technologies. Part of this change just comes from natural change resistance. These technologies are new. In some cases, they're unproven. And so there's a natural resistance to that change. Unfortunately, the lack of trust goes a little bit deeper than that, though. So we've all read about or heard in the news about AI implementations, even state-of-the-art implementations that just fall flat. And this has trained us all to be very suspicious of AI. Here at Vinsa, this problem is really near and dear to our heart. We see a couple of themes that come up that kind of cause these trust issues very often. And what those look like is the best state-of-the-art algorithms often use what are called black box techniques. These are things like, for example, with a deep neural network. It's an incredibly powerful tool. It's a pattern recognition machine. It's able to draw incredibly sophisticated patterns out of data. What it's very bad at is explaining its recommendations. And so unlike a human, you can't really go to this AI algorithm and say, why did you make that prediction? Why do you think that that's the case? So the black box nature of these algorithms is one challenge. A second, which is more fundamental, is just a lack of transparency into the performance of these algorithms over time. What you would like is for an organization to be able to roll out an AI solution in kind of a limited context, measure its performance, make sure that it's performing as intended, and then start to widen out the adoption or the implementation. That's a logical way to do it. Believe it or not, it's actually quite difficult to measure the performance of some of these algorithms without exerting a lot of effort. And then lastly, what we see is just these algorithms, even the best algorithms, have difficulty adapting to change or novelty. So think in say a nuclear facility or an energy production facility or an oil and gas rig, change is really the only constant. For a computer vision algorithm, you have different lighting scenarios, new types of equipment, a type of leak that you haven't seen before. What you would like, and this is how traditional computer vision or visual AI techniques approach these types of problems, is just train the algorithm before you roll it out on every possibility. Well, it's not possible. You can't cover every single corner case. And so algorithms being able to adapt to that novelty is very, very important. It's something we kind of take for granted with humans. We have an incredible ability to adapt past knowledge to novel situations. It's something that AI algorithms really struggle with. And so those are some of the challenges that we see on a recurring basis. These are the problems at Vinta that we're really focused on solving with our solutions, and we see these coming up a lot.
Nick, what is your take on this? Do you also agree with Daniel? What is your perspective on the challenges, especially from your experience within robotic inspection and pressure vessel storage tanks within the oil and gas sector?
Yeah, I mean, I would agree with that assessment. It's difficult to get new things kind of adopted, particularly if, as in the case of AI or machine learning, these things are kind of like people who learn on the job, and they take a lot of domain expertise to get them working right, which means you have to involve the end users. You got to pick the brain of the people that have been doing these things, and that means it takes a lot of their time, and that's difficult. And it's very important, if you have the opportunity as a fairly new startup to do a trial with one of these companies, that you're realistic about what you plan and what outcomes that you can expect and what success looks like. So those are challenges that need to be managed. I mean, you'll find in any of these companies, the large, multinationals, you'll find people who are in R&D whose job it is to go out and look for new robotic or AI solutions, but they're not going to make the decision about using it. It's going to be the plant management, and they're going to be, first of all, they're not going to have the time to devote to it, and they're not going to be as excited about changing the way they do things. In robotics itself, if you're trying to get a robot to work in a confined space, maneuver around, find its position, and then do some work, like there are robots that are bolted to the floor that have been making cars for decades, and they do it extremely well. But put a robot on give a screwdriver to a swimming robot and tell it to go find a screw and tighten it. We still haven't gotten there yet. So that in itself is a big challenge that needs to be worked on.
And what about cost? I mean, do you think companies are able to recover the costs over a period of time? I mean, the total cost of ownership. I know some robotic systems are quite expensive, which requires an upfront investment. Compare that with their production downtime, sending their workers to hazardous areas. So what do you feel, how does it cost at the unit economics fare when it comes to deploying a robotic system for inspection vis-a-vis using human labor?
As far as the storage tanks go, if we can solve the problem, it has a very positive economic impact. For example, if we're talking a refinery kind of one of the larger refineries on the Gulf Coast, they would budget $2 million to take a storage tank out of service. And that requires, first of all, emptying the tank. And when you empty a tank that's had liquid in it, it's got volatile organic compounds, which are dangerous. So you got to make sure those have all been evacuated. Then you cut a hole in it so you can go in there with a backhoe and clean the floor. Because the key with those tanks is to be able to inspect the floor of the tank. You can inspect the exterior for the most part from the outside. And use some kind of MFL scanning device to scan the floor and find any problems and repair them. And you want to find problems that are going to happen within the next few years because you don't want to go through that whole process again. So you do a lot of preventive maintenance. And then the inspector comes in. Now the inspector makes a couple $1,000s of that $2 million. So if you could, even charge 50 times what the inspector earns to put a robot in there and do the same job without taking it out of service, you've saved quite a bit of money. So there's definitely an economic incentive for that. For other things, it's a little more difficult to define the efficiency improvements other than the safety issue.
On you, Daniel, what is your take on the unit economic costs? Do you say there's a payback period or the ROI quickly for the industries or the energy sector which adopts these AI and computer vision, especially for inspection?
Yeah, good question. And I would agree with what Nick says. What we see typically is that there are very well-defined ROI cases. So there's definitely an economic incentive to adopt these technologies. The challenge is really just the unknown factor, the fact that this is a new technology, and because it's new, there are risks associated with that. Nobody wants to roll out and pay for solutions that don't work. And so just needing to have the confidence that these solutions are going to work, that they're going to deliver the value, that's really where the primary obstacle is that we see come up. But yeah, like Nick said, the economic incentives here are pretty compelling. If you can make a worker 20 times as efficient, you've now literally, you can either think of it as decreasing the cost of that worker by a factor of 20, or think of increasing the productivity and the economic value that one person can bring 20-fold. Those are just huge payback numbers. So.
We have seen dumb robots, and now I think the technology is as advanced. We are seeing machine learning as a current trend of robots. So going forward in the future, so what do you see would be the trends in the current robotic inspection? We have seen evolution from dumb robots to machine learning. So what do you think are the next few key takeaways in terms of technology trends when it comes to AI and computer vision? Where do you see the technology is heading for?
I see, we've had like mechanical, I don't know if you call them robots or mechanical vehicles that are remote operated by an operator sitting in far away in a safe space for a long time. They're not used very much because the quality of the data they collect isn't very good. Now using machine learning, AI, computer vision, we can make the robots a lot more precise. They're still for the most part remote operated, but they can kind of see where they are. The quality of the computer vision and what they can actually see and detect real problems are much higher. Sensor technology has gotten a lot better. You can put sensors everywhere you want, so that's gotten much better. I think the next generation has got to be autonomy. It's just figuring out how to have the robot actually understand where it is and maneuver by itself. And even in oil and gas, there's a lot of technology being developed for subsea. Now that's going to require sort of electrification subsea. It's going to require battery technology. It's going to require autonomous robots who can find out where they are and recharge themselves, and figure out where the bolt is and tighten the bolt by itself. Things like that. So that's those things are all in the future.
And you, Daniel, I know you're partnered with with Boston Dynamics to build Atlas robots and so on. So, what is your take on the next generation robots and AI, especially within the utilities and for the inspection purpose?
Yeah, I certainly agree with everything Nick said. You know, we're seeing those same trends, seeing some of that coming in the future. For us, we're very excited about the increased adoption of computer vision technologies. And more broadly, machine perception. As it relates to robotics, a very interesting trend that we're seeing develop is the use of computer vision technologies online to actually help guide and modify robot performance. So if you think about it, the way computer vision technology is being used right now is very much offline in batch mode. So robot goes out, captures a bunch of images, we store them, and then we use computer vision to analyze that offline. A trend that we're seeing develop is actually using that computer vision on the edge to analyze what we're seeing, what that robot is seeing in real time, and tell the robot, for example, move over here, move a little bit closer, take a higher quality image. And that's one trend. Another thing we're seeing that we're excited about is just the need and the opportunity to address the trust gap. And this is creating algorithms that are able to explain their predictions better, creating better tools to monitor performance of these algorithms, which builds confidence, and then creating algorithms that kind of have a sense of their limit. So they know when they're seeing something they haven't seen before, they're able to detect concept drift and ask for human support. And that really leads to the final thing I'd say, which is really near and dear to our heart. At Vinta, we really have this philosophy that the best AI is not an all or nothing approach. It's not about using AI to replace humans. It's really blending together what AI does uniquely well with what is uniquely human about human intelligence, the ability to adapt and adjust. And putting that together in a really seamless way, that's where we think the magic is going to come. And we're excited to just be part of the ride. I think those technologies are going to be exploding here in the coming years, and it's just very, very exciting.
Okay, gentlemen, I think it's been an interesting conversation. To recap, I think I understand definitely there are no unsurmountable barriers or challenges for adoption of robotics and AI, especially when it comes to inspection. The companies, be it global or the regional companies, are ready to adopt, even though there is kind of slight hindrance in terms of the adaptation to change. If that's only probably a slight challenge obstacle, which I see and I understand from this conversation. And I think to your point, Nick, I think there's been a tremendous improvement in terms of savings, as you mentioned, even 50 times the inspector charges. That means there's definitely a tremendous potential for AI and robotics in energy, especially when it comes to inspection within the oil and gas energy sector. Again, to your point, Daniel, about how the companies are embracing AI and computer vision within the robotics for the energy sector, I think that's just proven a point that going forward, we would definitely see major advancements as I mentioned, from dumb robots to machine robots to probably to the next generation robots with more accurate work and optimization of design and of course scheduling of these robots and so on. And thank you, gentlemen. It was a pleasure meeting you for this panel discussion. Thank you once again for joining this CERA Week Agora Conversation, presented by WD.
Thank you.
Thanks, Vinod. Thanks, Daniel. Enjoyed it.
Thanks, Rick. Thank you, Daniel.